we've got here is our interference movement. All right, so what we're looking at are two sources here, point sources. They cause the waves to happen. You guys can do this at home. Take a big old turkey basting pan. Get your study buddies. I know you guys have them. You're supposed to. One person dips one finger in one place. That finger should never move. It always taps the same place in the water. The other person, another finger. Go like this. Be like the little dunking birds. You guys are going to cause a wave pattern like this. All right? Like that. Now, what happens is these waves interact with each other. You start to see a pattern here. So the first pattern I want us to see are the little white circles. These are the crests. Remember, crests are the tops of the waves. What are the bottoms of the waves? Troughs. All right, so just the crests, just the white ones. All right, so we've got one here. Curves around. We've got one here. Like that. Got a bigger one. Now, up close, they don't interact too much. Now, when we start having the other point source, we start to see interactions and interference. Okay? This is called an interference pattern. That should go in your notes. It's very important. It's what happens when light waves, any kind of waves, interact. Interference patterns. Interference is spelled up here, and then pattern. All right, so these are the pattern of crests. That's all the top parts. Here's where we start seeing our second wave interact. Oh, I'm already seeing a pattern. Do you guys see it? Yeah, some of you do. All right, so here where they crisscross, I'm seeing points of bright white. Huh, that's kind of funny looking. Why is that a brighter white than the rest of it?
Because it's two the same.
It's two of the same thing. Here, I'll show you. We have here an origin. All right, that's the center line. Here's our first wave. Comes up, comes down, comes up again. That's our first wave. Now, our second wave looks exactly the same. Exactly the same. So it's going to overlap. Exactly the same as that. See? Same amplitude. Positive, negative. Negative amplitude is just when it's below the origin. Okay? It's exactly the same. It's just below the origin to make it negative. Now, if I add two crests together, two positive amplitudes, I get an even bigger amplitude that is equal to both of them added together. Are we okay with this? Two big ones, we add them together. Make sense? Two big waves make a really big wave, the big kahuna. Anybody surf? Yay, one brave soul. So, the big kahuna, the added wave, is going to look like this. It has twice the amplitude. Goes up, peaks up there. This comes down. The trough is down there. So let's see if I'm in my short self can reach this. All the way up, down, all the way down, and back up again. This remains 0 because this curve and this curve are both 0. 0 plus 0 equals 0. So that's not going to move. This is a node. All right, double tall, double deep. Okay, this is a trough, that's a crest. Now, what we're looking at, this tall part, those are the white spots. Those are the really tall ones. This really deep part, the deep trough, see these dark spots here? Huh. Do you think these dark spots correspond to this deep trough?
Yeah, sure.
Yes, they do. Okay? Really bright spots, really tall. Really dark, really deep. Now, what are these funny looking lines here where nothing is going on? It's just kind of a gray, plain line. Looks like this. You guys see it? There's one. You see this one?
Yeah.
All right, here's the next one. What do you suppose is happening here, folks?
No interference.
No, we do have interference. Whenever you have multiple waves existing at the same time, you have interference.
Is that the middle line?
That's the middle. This is where they cancel completely. Okay? Now, what this looks like is a little different. All right, I highly recommend drawing these curves in your notes. It makes it way easier to remember what it means. All right, I'll redraw my origin here. All right, so here's our starting curve. Comes up, comes down, goes down, comes up. Complete waveform. Now, this is an area where it cancels. This is what happens when two waves are 100%, 100% is all the way, out of phase. That means they are completely the opposite. All right, so it looks like this. Here's our first wave. Here's our second. That's a little problematic. Does our curve actually look like this? Not so much. We do not have a googly eye curve. What actually happens is this amplitude, which is positive, and is exactly equal and opposite to this amplitude. Yep. Remember, if it's above the origin, it's positive. If it's below the origin, it's negative. Mount Everest is very tall. It's above sea level, positive. Death Valley, not so much. I think Death Valley is the lowest part of the United States. It's below sea level. But these opposite amplitudes will cancel. Same here. Okay, do you see how that works? They will cancel. What we end up with is this. Our waves have flatlined, to the end of our waves. They're not destroyed, they are merely canceled. That is why we have these little gray rays right here where nothing happens. Because at these lines, that's where we have a crest meet a trough, and a trough meet a crest. Does this make sense? Yes. Okay. Trough, I'll draw a new curve. Okay. Trough is down here. Trough. Like horses will drink from a trough, like a bucket on the ground. Okay? Trough. You can fill it with things. This is a crest. Also called a peak. The Angeles Crest Mountains, peaks. They're the top parts. We all good? All right, let's move on. Yes.
Will the crest and the trough, like on one single line, ever cancel out each other?